Section 400.7 of the National Electrical Code permits the use of flexible cords for wiring luminaires, commonly known as fixtures. Conversely, Section 400.8 restricts the use of flexible cords, stating they shall not be used as a substitute for the fixed wiring of a structure or be attached to a building surface unless specifically permitted by 400.7. Understanding the scope of specifically permitted is crucial for proper application. The National Electrical Code does not impose a specific distance limitation for running flexible cord from a branch circuit to a fixture. However, a general recommendation is to minimize the length of the flexible cord run. This practice helps reduce potential hazards and ensures safer installations. The prohibition against attaching flexible cords to building surfaces is generally strict. The only exception explicitly mentioned relates to Section 368.8, which pertains to busways. This means that unless a specific provision within the National Electrical Code clearly allows it, attaching flexible cords directly to building surfaces is not permitted. The term specifically permitted in 400.8 underscores the importance of finding an explicit allowance within the code for using flexible cords in a particular manner. It emphasizes that assumptions or interpretations are not sufficient justification. A clear and direct statement in the National Electrical Code is required. For luminaire installations in greenhouse environments exposed to weather, the standard approach involves using conduit or other approved raceways. These raceways provide essential protection for the electrical wiring against environmental elements. Flexible cords, in this scenario, are best suited for the final connection to the luminaires. Several additional factors must be considered when working with flexible cords. Firstly, ensure the cord is adequately protected from physical damage. Secondly, verify that the cord's rating aligns with the intended application, considering voltage and environmental conditions. Thirdly, avoid exceeding the cord's allowable ampacity, which is the maximum current it can safely carry. Fourthly, implement a routine inspection schedule to check for any signs of damage or deterioration. Following these guidelines enhances safety and prolongs the lifespan of the flexible cord. To elaborate on the practical application of these code requirements, let's consider a scenario where you are installing a series of luminaires in a greenhouse, each requiring a connection to a 120 volts branch circuit. The luminaires are to be suspended from the greenhouse ceiling, approximately 35 feet above the ground. Given the environmental conditions and the need for a secure and compliant installation, several key steps should be taken. Firstly, begin by installing a rigid conduit system from the branch circuit junction box to a point near each luminaire location. This conduit serves as the primary protection for the electrical conductors against moisture, temperature variations, and potential physical damage, all of which are common in greenhouse environments. Secondly, at the termination point of the conduit, install a junction box that is rated for outdoor use, typically an enclosure with an M4 or a Fowlkes rating to provide protection against water ingress and corrosion. This junction box will serve as the transition point from the rigid conduit system to the flexible cord connection to the luminaire. Thirdly, select a flexible cord, such as a 40-3 SU cord, that is specifically rated for outdoor use and exposure to moisture and UV radiation. This SU designation indicates that the cord is oil-resistant, suitable for outdoor use, and water-resistant. Ensure that the cord's opacity is sufficient for the luminaire's operating current, typically 15 amps for a 14-gauge cord. Fourthly, connect the flexible cord from the junction box to the luminaire, using appropriate strain relief connectors at both ends to prevent tension on the conductors. These connectors should also be rated for outdoor use and provide a watertight seal to maintain the integrity of the electrical connections. Fifthly, securely suspend the luminaire from the greenhouse ceiling using appropriate hanging hardware, such as chains or cables, that are rated for the weight of the luminaire. Ensure that the luminaire is installed at the correct height and orientation to provide optimal lighting for the plants. Sixthly, regularly inspect the flexible cord and all electrical connections for any signs of damage or deterioration. Pay close attention to the cord's insulation, connectors, and strain relief devices. Replace any damaged components immediately to prevent electrical hazards. In addition to these practical steps, it is important to consider several other factors to ensure a safe and compliant installation. Firstly, ensure that all electrical work is performed by a qualified electrician who is familiar with the National Electrical Code requirements for greenhouse installations. Secondly, obtain all necessary permits and inspections from the local electrical authority to ensure that the installation meets all applicable codes and regulations. Thirdly, provide adequate grounding for all electrical equipment, including the luminaires, junction boxes, and conduit system. This is essential for preventing electrical shock hazards and ensuring the proper operation of overcurrent protection devices. Fourthly, use ground fault circuit interrupter protection for all branch circuits that supply power to the luminaires. This will provide additional protection against electrical shock hazards, especially in wet or damp environments. Fifthly, consider the use of surge protection devices to protect the luminaires from voltage surges caused by lightning or other electrical disturbances. This is particularly important in areas that are prone to thunderstorms. Sixthly, provide adequate ventilation for the luminaires to prevent overheating, which can damage the electrical components and reduce the lifespan of the lamps. This is especially important for enclosed luminaires. In summary, the installation of luminaires in greenhouse environments requires careful planning, attention to detail, and adherence to all applicable codes and regulations. By following the steps outlined above and considering the additional factors discussed, you can ensure a safe, compliant, and reliable electrical installation that provides optimal lighting for your plants. Regarding the interpretation of Section 400.7 and 400.8, it is important to understand that the National Electrical Code is a comprehensive set of guidelines that are intended to ensure electrical safety. The code is constantly evolving to reflect changes in technology and industry best practices. Therefore, it is essential to stay up to date on the latest revisions to the code and to consult with a qualified electrician or electrical engineer if you have any questions about the interpretation or application of the code requirements. To further clarify the use of flexible codes, let's examine some specific examples of situations where their use is permitted or prohibited. Firstly, portable lamps and appliances are commonly wired with flexible cords, as this allows for easy movement and connection to a power source. This is a permitted use of flexible cords under Section 400.7 as it is specifically designed for portable equipment. Secondly, pendant luminaires that are suspended from the ceiling are often wired with flexible cords, as this allows for adjustment of the luminaire's height and position. This is also a permitted use of flexible cords, provided that the cord is not subjected to excessive strain or physical damage. Thirdly, temporary wiring for construction sites or other temporary installations is often done with flexible cords, as this allows for quick and easy setup and removal. However, this use is subject to certain restrictions, such as the duration of the temporary installation and the type of environment in which the wiring is installed. Fourthly, as previously mentioned, the final connection to luminaires in greenhouse environments is often made with flexible cords, as this allows for flexibility in positioning the luminaires and making adjustments as needed. However, this use is subject to the requirement that the flexible cord is protected from physical damage and environmental conditions. On the other hand, there are several situations where the use of flexible cords is prohibited. Firstly, using flexible cords as a substitute for permanent wiring in a building is strictly prohibited under Section 400.8. This includes running flexible cords through walls, ceilings, or floors, or using them to supply power to fixed appliances or equipment. Secondly, attaching flexible cords to building surfaces such as walls or ceilings is also generally prohibited, as this can create a tripping hazard and subject the cord to physical damage. Thirdly, using flexible cords in wet or damp locations without proper protection is prohibited, as this can create an electrical shock hazard. Fourthly, exceeding the allowable ampacity of a flexible cord is prohibited, as this can cause the cord to overheat and potentially start a fire. In addition to these specific examples, it is important to note that the National Electrical Code also contains general requirements for the use of flexible cords, such as the requirement that they be properly supported and protected from physical damage, that they be connected to appropriate terminals and devices, and that they be used only for their intended purpose. By understanding these requirements and following them carefully, you can ensure that your use of flexible cords is safe, compliant, and reliable. Moreover, consider the selection of the appropriate type of flexible cord for the intended application. Different types of flexible cords are designed for different purposes and environments, and it is important to choose a cord that is suitable for the specific conditions in which it will be used. For example, SU cords are commonly used for outdoor applications, as they are oil-resistant, water-resistant, and UV-resistant. SU cords are similar to SU cords, but they are designed for lighter-duty applications. Furthermore, it is crucial to regularly inspect flexible cords for any signs of damage or deterioration. This includes checking the insulation for cracks, cuts, or abrasions, as well as inspecting the connectors and terminals for loose connections or corrosion. Any damaged or deteriorated cords should be replaced immediately to prevent electrical hazards. Flexible cords can be a convenient and versatile wiring method, but they must be used properly and in accordance with the National Electrical Code requirements. By understanding these requirements and following them carefully, you can ensure that your use of flexible cords is safe, compliant, and reliable. To provide more clarity on the installation practices for luminaires in greenhouses, let's explore the specific requirements related to wiring methods and environmental considerations. Firstly, the National Electrical Code requires that all wiring in greenhouses be suitable for wet or damp locations. This means that the wiring must be installed in a raceway, such as conduit, or be of a type that is specifically listed for use in wet locations. Secondly, the National Electrical Code requires that all electrical equipment in greenhouses be grounded. This includes the luminaires, the junction boxes, and the conduit system. Grounding is essential for preventing electrical shock hazards and ensuring the proper operation of overcurrent protection devices. Thirdly, the National Electrical Code recommends the use of ground fault circuit interrupter protection for all branch circuits that supply power to luminaires in greenhouses. Ground fault circuit interrupters are designed to detect small amounts of current leakage to ground and to quickly interrupt the circuit, thereby preventing electrical shock hazards. Fourthly, the National Electrical Code requires that all luminaires in greenhouses be installed in accordance with the manufacturer's instructions. This includes following the manufacturer's recommendations for mounting height, spacing, and wiring connections. Fifthly, the National Electrical Code requires that all luminaires in greenhouses be protected from physical damage. This can be achieved by installing the luminaires in a location where they are not likely to be struck by objects or by providing a physical barrier to protect the luminaires from damage. In addition to these specific requirements, there are also some general considerations that should be taken into account when installing luminaires in greenhouses. Firstly, the luminaire should be selected to provide the appropriate amount and type of light for the plants being grown. Secondly, the luminaire should be positioned to minimize shadows and provide uniform light distribution. Thirdly, the luminaire should be installed in a way that allows for easy maintenance and cleaning. Fourthly, the luminaire should be energy efficient to minimize operating costs. By following these requirements and considerations, you can ensure that your luminaire installation in a greenhouse is safe, compliant, and effective. To expand on the topic of selecting the appropriate type of flexible cord, it is essential to consider the specific environmental conditions and the intended use of the cord. Different types of flexible cords are designed to withstand different levels of exposure to moisture, chemicals, temperature variations, and physical stress. For example, in a greenhouse environment where the cord is likely to be exposed to moisture, humidity, and occasional splashes of water, a water-resistant cord such as SU or SU is recommended. These cords have a durable outer jacket that protects the conductors from moisture and prevents corrosion. In addition, the W designation in the cord's name indicates that it is specifically designed for wet locations. If the cord is also likely to be exposed to oil or other chemicals, an oil-resistant cord such as SU or STU is recommended. These cords have a special outer jacket that resists the degrading effects of oil and chemicals. In environments where the cord is subject to extreme temperatures, such as in a hot or cold storage facility, a temperature-rated cord is recommended. These cords are designed to withstand the specific temperature range of the environment without becoming brittle or melting. In applications where the cord is likely to be subjected to physical stress, such as in a construction site or a factory, a heavy-duty cord such as SU or CU is recommended. These cords have a thicker outer jacket and reinforced conductors to withstand abrasion, impact, and other types of physical damage. In addition to these environmental considerations, it is also important to consider the ampacity of the cord. The ampacity is the maximum amount of current that the cord can safely carry without overheating. The ampacity of a cord depends on the gauge of the conductors and the temperature rating of the insulation. It is important to select a cord with an ampacity that is sufficient for the load that it will be carrying. To determine the appropriate ampacity for a cord, consult the National Electrical Code Table 400.5a. This table provides the allowable ampacities for different types of flexible cords based on the gauge of the conductors and the temperature rating of the insulation. It is important to note that the ampacity of a cord may be derated under certain conditions, such as when the cord is installed in a conduit or when it is exposed to high ambient temperatures. If the cord is to be used in a derated condition, the ampacity must be adjusted accordingly. Furthermore, consider the length of the flexible cord run. Longer cord runs will experience a greater voltage drop, which can affect the performance of the connected equipment. To minimize voltage drop, use a larger gauge cord for longer runs. To calculate the voltage drop in a flexible cord run, use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant equal to 12.9 ohms for copper and 21.2 ohms for aluminum. I is the current in amps. D is the one-way length of the cord in feet, and circular mils is a cross-sectional area of the conductor in circular mils. The National Electrical Code provides tables with conductor properties in Chapter 9. Additionally, ensure that the flexible cord is properly supported and protected from physical damage. Flexible cords should not be used as a substitute for permanent wiring and should not be run through walls, ceilings, or floors. Flexible cords should be supported by strain relief devices at both ends to prevent tension on the conductors. Flexible cords should be protected from abrasion, impact, and other types of physical damage. Flexible cords should be regularly inspected for signs of wear and tear. Any damaged or deteriorated cords should be replaced immediately. In summary, selecting the appropriate type of flexible cord requires careful consideration of the environmental conditions, the intended use, the ampacity, the length of the run, and the need for support and protection. By following these guidelines, you can ensure that your flexible cord installation is safe, compliant, and reliable.